Hello, class. I hope everyone's doing well on this afternoon for me recording this. We are going to talk about the reactivity of metals in the series in which we can rank different metals based on their reactivity. So, um, let's get started. Our first slide first defines the reactivity series of a metal. So, it is a list of metals' reactivity. It is determined by watching metals react with water, acid, or in displacement reactions. And then it will show that metals will either lose their valence electrons to form positive ions or how they will react. So, for example, this is what a reactivity series of metals looks like. We have at the top the most reactive being potassium, and on this side we have our abbreviations of each element, but we have our potassium, our sodium, calcium all the way down. We've learned from earlier this week when we learned about reactivity, and last week when we were learning about families and groups of the periodic table, why our potassium and sodium, being our alkali metals, are so reactive. Just having one electron, they like to react to get rid of that electron. And so these elements that are higher up are going to be are easier to become stable, usually just have one electron. These ones farther down are much more stable normally. It is hard for them to gain or lose their electrons. So things like gold and platinum are very, very stable and are used for a lot of different things. So we're going to break down each type of reaction that we use to determine how different metals are more or less reactive, and then explain kind of what happens and how we can use that to help us list and create our different series. So first off, we're going to be talking about water and metals reacting. So anytime we place different metals in water, so when metals are mixed with water, they form metal hydroxides with hydrogen gas. So a hydroxide is an OH right here. A hydroxide is this, and our metal is sodium. So anytime we put sodium in water, we are creating sodium hydroxide and hydrogen. So oftentimes, not often, but in our alkali metals, what happens is we will create this hydrogen, which then will catch fire because our reaction is so hot. So we've seen a couple different videos of our alkali metals reacting with water and causing explosions, and it's because this hydrogen gas gets ignited whenever it's formed. So not all metals will react with water, only the most reactive ones, which is important to remember. The most reactive can be measured by the highest increase in temperature. So if we had a thermometer in our water and just measured the temperature before and after we place our metal in there, that would allow us to determine what is most reactive. Our second type of reaction is acids with metals. So I thought it would be important to define an acid, which is something that gives protons and gets electrons. So acids likes to give up an H plus, and it will take electrons from the other molecule or compound. So when an acid and metals are mixed, they form a salt and hydrogen gas. So looking at our good example over here, we have our metal being calcium and our acid being HCl, which is hydrogen chloride. So we will put them together, and then this AQ means that this acid also has a little water in it, but we'll put them together, and this calcium will form with our chloride to make a salt. This will be our salt, and we will produce our gas just like we did in our water one. We also have another example where we have aluminum with this acid. Our aluminum will go with, this is our nitrate group. NO3 is a nitrate. So our aluminum will go with our nitrate, and we will produce more gas. So a lot of the times this gas will catch fire, just like our water, just like when it did when we reacted with water. And the more explosive or the more reactive, the higher it is on the list, just like we would put it for our water. So the last thing we're going to talk about is our displacement reactions. So displacement reaction is the more reactive metals will displace or replace the less reactive ones. So so this helps us determine which element is more reactive by seeing which molecule will form at the end. So for example, if we have A and B in one molecule plus another molecule C, and we combine them and we come out with a B and a C, that means that C was more reactive than A. So for example, if we wanted to use potassium as our C, and aluminum as our A-B combination. So, or maybe it's aluminum, or let's do a different one. So sodium chloride, let's use salt and potassium. So sodium chloride is going to be our AB. Our C is going to be potassium. Since potassium is more reactive than sodium, we would get a sodium molecule and then we would get a potassium chloride molecule over here. So we would get a new salt formed. If, for example, the C molecule is less reactive than the A molecule, then it will stay just as it is on the left side. There will be no reaction. So this is another example. Calcium will displace zinc, but copper won't displace iron. So calcium on our list will displace zinc or anything below it, but our copper molecule down here won't displace anything above it. So we can use these all to help us determine and create our own lists. So we have an activity to do today about creating our own list, another video for kind of how I was hoping you guys could do that. But I hope this was clear. If you have any questions, please let me know.